Good morning, everybody at home. Can I get a thumbs up that you hear me and see the board okay? Awesome. All right. I'm just gonna go over some of the homework problems that I've assigned you. I told you that you didn't actually have to start it if you didn't want to. I didn't make it due until tomorrow night. So if this helps anybody, even if you've already done it and you weren't quite sure, this hopefully could help clear some things up for you. So I've just taken some problems off of my math lab and pasted them on here for us to kind of run through to see if it helps anybody understand a few things as we're moving through. So I put at the top of the notes just your one cycle, one period of the cosine and the sine function. We have the sine wave that starts at 0, 0. We have the cosine wave that starts at 0, 1. And then they each take 2 pi radians to complete one cycle. And then all the outputs start to repeat themselves. So I've given you the important information for each graph, their domain, their range, their key points, and stuff like that. The transformations that we are working on in this section, guys, they only affect your stretching and shrinking. It's going to change the shape of the graph in the sense that it's stretching it bigger or smaller or stretching it this way or shrinking it in horizontally. We're not doing any phase shifts. So it's not like we're bumping anything to the right or bumping anything to the left or bumping anything up or anything down. This is straight up stretches and shrinks. So to do those types of transformations, it requires multiplication. So if you multiply the outside of a function by a, that'll affect your y coordinates and it'll be a vertical stretch or shrink. If you multiply the x's by omega, then you'll be causing you'll affect the x's and you'll create some type of horizontal stretch or shrink. All right, so that's all we're worried about right now. And then if you do that, if you stretch or shrink your graph horizontally or vertical, you have the potential to now change the amplitude or now change the period. So these are the things they want you to be able to identify. Which change? The amplitude, the period, both? What is the new amp? What is the new period and whatnot? All right, so just remember, the amplitude is half the distance between the highest and lowest point. It's how many units up and how many units down you went from that midline. So technically the amplitude of each original trig function sine and cosine was 1. So the new amplitude will be whatever you times the outside of the function by. But we always describe amplitude as a positive number. So it'll be the absolute value of whatever you multiplied the outside by times 1, the original amplitude, which literally just makes it the absolute value of A. It'll be the absolute value of that front number. All right, and then your period, the original period of each trig function, sine and cosine, is 2 pi units. So if you're going to multiply the x's by omega, that's going to affect our x coordinates. But remember, the inputs always have the opposite effect. So if it says omega times x, it's actually your x is being divided by omega. So your period, which used to be 2 pi, will be divided by omega. And that's how you'll find your new period. And then I had you guys yesterday, once you get your new period, you can divide your new period by 4, and that's how you'll know what to count by. That's how you'll know where each key point will be located or what you're going to count by. All right, here we go. Let's try the first one. So guys, this is a problem from the homework. It says determine the amplitude and period of the following function without graphing. So they've given you this function. Clearly it's a sine function. They want you to find the new amp and the new period. Well, guys, I times the outside of this function by 7. So my amplitude will be the absolute value of 7 times 1, the original amplitude, which is the absolute value of 7, which is 7. That means this graph will go 7 units up and 7 units down from the midline. Okay? Well, what about the period? I have taken the x's and I have times them by pi. Well, what's that going to do to the period of my graph? My period, which used to be 2 pi, is now going to be divided by omega because my x's are, well, I say omega. In this case, the omega is pi. They're being divided by pi. Whatever you do to x has to get done to that period. So guys, if I'm going to take my x's and times them by pi, I know my x's are really being divided by pi, so I'm going to take my period and divide it by pi as well. And then that cancels my pi out, and it's 2. So guys, if you can imagine this, you are dividing your increment, right? It used to take 0 to 2 pi to create one cosine or one sine wave. But guys, at the end of the day, 2 pi is the number 6.28. It's 6 times 3.14. So it takes us getting to about 6.28 to create one cosine or one sine wave. Now they're just telling you it's going to take 2. So you're only going to get to the number 2, and you'll have already created a cosine wave. So it's a much smaller. So you'll be able to fit more cosine waves in that increment of 0 to 2 pi. You've changed the period, the amount of inputs. Technically, what you've done is you're dividing it by pi, which is 3.14. So you're chopping this interval, 2 pi, into 3.14 sections. And you should be able to fit 3.14 cosine waves in that interval of 0 to 2 pi now. All right? And that's your new amp and your new period. You type them in and you hit enter and you're good to go. All right? Look at this one. Now, I changed this. If you're at home, and guys, if you're here, I wanted to show you this as a sine function. I just couldn't get an example to come up. So we already have seen cosine. We know that we don't want a negative argument. So we know we can rewrite this as y equals 3/5 cosine of 2 pi over 5 times x. That even function says you can take the negative out and it becomes positive on the outside. So I wanted to do this as a sine function because the sine function is odd, and then that can be a little bit different the way you rewrite it. Okay, so one of the first things they want you to do is if you have a negative argument, if what you're taking the sign of is negative, they want you to use your even or odd function behavior to rewrite that. So we know if it's the sine of a negative angle, we can rewrite that as the opposite, the negative sign of that angle. You can take the negative out and throw it on the outside, because it's an odd function. So when you plug the opposite of theta in, the opposite of that ratio comes out. So we can rewrite this as y equals, take that negative, we're going to throw it in front on the outside. So negative 3/5 times the sine of 2 pi over 5 times x, because it's an odd function. Okay, so now let's get our amp and our period. The amplitude, well, guys, now that we have a negative leading coefficient like that, that means there's been an x-axis reflection. You're timesing your y values by a negative. So now all the y values that were up here are down there. All the y values that were down here are up here. All right, so there's definitely an x-axis reflection going on with this transformation. However, they just want to know the amplitude. So the amplitude will be whatever you timesed the outside of your function by, which is negative 3/5, times the original amplitude 1, and you take the absolute value of it. So it's 3/5. It'll be 3/5 up and 3/5 down from that midline. All right, our period. Well, guys, in this function, you are multiplying your x's by 2 pi over 5. So in reality, your x's are getting divided by 2 pi over 5. So we're going to take our period, which was 2 pi, and we're going to divide it by 2 pi over 5. Now we have a complex fraction. Let's fix that. So I'm going to multiply by the reciprocal. Multiply by the reciprocal, and now 2 pi's cancel, and your new period is 5. So now it only takes 5 units to create one cosine, or what is a sine? One sine wave. So guys, again, if you can picture this, it used to take 2 pi units to create that one sine wave. Well, now that's 6.28. Now it's only going to take 5 units to create that sine wave. So I can't get it. You've horizontally shrunk that curve to only take 5 units to create it, not 6.28 units to create it. So you'll be fitting more waves in that interval. All right, is everybody okay so far? Nice and easy, hopefully, when you see it like this and you're not creating the whole graph. All right, let's go to the next one. The next one says, before I hurt myself, match the function y equals 5 cosine pi over 2x to the correct graph. All right, well, guys, picture this. This is a cosine graph, right? So cosine starts up at 1. So we're looking for the seagull. The sine started at 0. We have not transformed these graphs to bump anything up or down. So unless there's been an x-axis reflection and now cosine looks like this, because it's been reflected over the x-axis, or sine now looks like this, because it's been reflected over the x-axis, everything should still start at 1 or 0, or maybe 0 or -1, depending on whether or not it's been reflected. So if this is going to be a cosine graph, get rid of the sine ones immediately. Guys, this one started at 0. That is not a cosine graph. This one started at 0. That is not a cosine graph. And now we'll pick our answer depending on what our amplitude should be and what our period should be. How many units should it take to create one cosine wave now? Well, guys, look at our amplitude. We're multiplying the outside of the function by 5. So our amplitude is going to be the absolute value of 5 times 1, which is 5. So now you're looking for the cosine curve that goes 5 units up and 5 units down. Guys, this one only went 2 units up and 2 units down. It couldn't be that one. This one went 5 units up and 5 units down. It looks like he's a winner. And let me just finish it off by giving you, definitely, look at what the period needs to be. Your period is 2 pi divided by, you times your x's by pi over 2. So in reality, you're dividing by pi over 2. So if you divide by pi over 2 and then clean that up, your new period is 4. It should take 4 units to create one cosine curve. So guys, look, it went 5 units up and 5 units down, and it went from 0 to 4 to create one cosine curve. So that's definitely the graph that we want. So it's definitely graph B. It has the correct period. It has the correct amplitude. It has not been reflected over the x-axis. That's definitely the graph that we want. Okay? All right. And again, if you have any questions, please feel free. Okay, so now they're going to give you information. Now you have to write the equation of the function, given its period, given its amplitude, which is just us plugging into a formula, really. All right, so this one says, write the equation of a sine function with amplitude 5. And guys, I changed this. The period is normally 2 pi, so that means you didn't make any changes to your x's. I'm going to change that. Let's say the period was 7 pi, just to make it a little bit more interesting. Okay, well, they've given you either this formula to go off of, or they've given you this formula to go off of. All right, and you have to find out what your A value is and your omega is, given the amplitude and the period. They've asked us to write the equation of a sine function here, so we're definitely going to use this formula. Okay, it says we have to have an amplitude of 5. So guys, what do I need my front number to be in order for this sine wave to have an amplitude of 5? Now, technically, there's 2 options. It could have been a positive 5, and my graph would have an amplitude of 5, but it also could have been negative 5, and my graph still would have had an amplitude of 5. I'm not looking at a graph where I can tell whether or not it's been reflected over an x-axis or not, and I need to make it negative. So because I'm not looking at the graph, I have 2 options. Right now, my amplitude to have an amplitude of 5 could have been plus or minus 5. So if the amp equals 5, then right now we have y equals plus or minus 5 times the sine of omega x. That's what we know so far. All right, now I need omega. What did they times x by in order to make the new period of this function 7 pi? Well, guys, think about it. Think about how we find the period, right? The period is us taking 2 pi and dividing it by omega. That's always how we find the new period. If they're going to take the x's and times them by omega, we're going to take the period and divide it by omega. So when we took 2 pi and we divided it by omega, it ended up equaling 7 pi. It's the new period. And now we're going to cross multiply and we're going to solve this equation, this proportion for omega. What does omega need to be to make this true? So when I cross multiply, I get 7 pi times omega equals 2 pi. 2 pi times 1. And now you're solving for omega. What was in our equation to make our period 7 pi? So I'll just divide by 7 pi. And now omega must have been 2/7. I must have multiplied the x's by 2/7 to create a period that was 7 pi units. Now guys, our pi's canceled. but it doesn't have to. Not every single time is pi going to cancel. Sometimes your omega will have a pi in it, and that's perfectly fine. So now we know this. Y equals plus or minus 5 times the sine of omega is 2/7 times x. And that would have been the function. So now you're picking the option where it says there are two equations. The equation when a is less than 0, when a is negative, is y equals -5 sine 2/7 x. And the equation when a is greater than 0 is y equals +5 times the sine of 2/7 x. All right? Now, again, you don't want to pick this one because they're saying there's two equations, but they're saying there's two equations when omega has two options. Omega doesn't have two options. It's the amplitude number that could have been positive or negative, okay? All right, perfect. How did that feel? Everybody all right? Good? Okay. Same thing. Now they want you to write the equation given a graph. Looking at the graph, what did the equation have to be? So you're going to have to pick off the graph, your amplitude, your period, and whether or not it's been reflected over the x-axis. Does your A number have to be positive because there was no x-axis reflection? Or does your A value have to be negative because there was an x-axis reflection? So again, just to remind you, the sine wave should look like this. If it's been reflected over the x-axis, it'll look like that. It'll go down and then up. So this is with an x-axis reflection. And then your cosine wave is supposed to start up at 1, go down, and come back up. If it had an x-axis reflection, it would be reflected and start down here and go up and come back down. So that's a cosine wave with an x-axis reflection. Okay, so here we go. Looking at the graph, first you want to decide, guys, is it a cosine or a sine wave? Look at this graph. It starts up, goes down, and ends up. That's definitely cosine. That's our seagull, right? And again, because I can say that confidently in the sense that we haven't shifted anything right or left yet, where it could have been a sine wave, but I've shifted left or right. It's not been shifted left or right yet. So if it's going to start up, it's got to be a cosine wave right now. So now we know we're using this formula. Y equals A times the cosine of omega x. Well, guys, let's look at the graph. Let's see what our amplitude is. This cosine went up to 6/7 and it went down to -6/7. So it went up 6/7 units and down 6/7 units from that midline. So clearly our amplitude is 6/7. But do I want it to be a positive 6/7 or a -6/7? Guys, has this cosine wave been reflected over the x-axis if it still starts up? No. So you want A to be a positive number, and we want it to be 6/7. So right now we know the amplitude is definitely 6/7, and we want A to be a positive number because there's no x-axis reflection. All right, so right now we know our formula is Y equals positive 6/7 times the cosine of omega x. So now we need omega. Well, look at the curve and see how many units it took to create one cosine curve. Find your period. So guys, it went up, it came down, it went back up. So this is where it ends right there. Now it's going to start over again. So my new period is 1/2. It only took 1/2 of a unit to create one cosine wave. So your period is 1/2. Well, what did omega have to be to make your new period end up as 1/2? So think about it. We would have taken the period 2 pi, we would have divided it by omega, and then that would have ended up equaling 1/2. So now we're going to cross multiply and we're going to solve this for omega to see what was in our equation. So I'm going to get omega times 1, that's omega, equals, so guys, it's already going to get you your answer. 2 pi times 2 is 4 pi. There must have been 4 pi times x to create this new period of 1/2. So now we know y equals 6/7 times the cosine of omega, which was 4 pi times x. And then that will create that curve. Is everybody okay with that? Everybody good at home? Yes? Hopefully this is a little bit helpful. If you haven't done the homework yet, if you've struggled all the way through, I apologize. All right, let's do one more looking at a graph, and then that's all the examples I have for you. And then can I just remind everybody, The only other questions I believe on your homework for the most part were like you actually physically had to use the graphing tool yourself to graph these functions. I just want to remind you that when you open up that graph and you click here to graph, make sure you click that little icon of the cosine or the sine wave, depending on which one you're graphing. And then if I'm clicking on sine, because I'm graphing sine, I always click the point 0, 0 to get me started, because that's where sine starts. And then I'll put in my transformations, my vertical or horizontal stretches. And then if I'm graphing cosine, I click the cosine icon, and then I always click the point 0, 1 to get me started, because that's always a point on the original cosine wave. And then I'll put in my transformations, all right? Okay. All right, last one. And I apologize, you'll see in a second. If you're looking at this graph, is it a cosine wave or a sine wave? Remember, because we haven't moved up or down yet, if it doesn't start at 0, 0, it ain't sine. So this has to be another cosine one. Couldn't get an example to come up with sine. I only had so many options to pick out of, so I apologize that I didn't give you an example with sine. But we're doing another cosine. But guys, this time, if you notice, the cosine, it started down. It went up and then ended down as well. So this is definitely a cosine curve that has been reflected over the x-axis, which means you definitely want that a value to be a negative number now. All right, so we have our formula. Okay, the amplitude, well guys, it only goes 1 unit up and 1 unit down. So it's not necessarily different. The amplitude is still 1, but what do I want my a value to be in terms of sine? If I need it to be reflected over the x-axis, I need it to be negative. So my amplitude is 1, but I need that a value to be negative in order to create that x-axis reflection. So now I'm going to put y equals -1, or really they would just put a negative sign, times the cosine of omega x. Now I got to figure out what's my omega, what's my period, what do I need to put in this function to create it? All right, let's go to the graph. To create one cosine wave, I went up, I came back down, and I ended. And now I'm going to start all over again. Your period is 4 pi over 5 units. So now my period is 4 pi over 5. Well, think about how we would have found that period. We would have taken 2 pi and divided it by omega, and it would have ended up equaling 4 pi over 5. So now we'll solve this for omega. Cross multiply. I'll get 4 pi omega equals 10 pi. We're solving it for omega, so divide by 4 pi. My pi's cancel, and 10 over 4 reduces to 5 halves. So omega must have been 5 halves. So now we can say y equals the opposite of cosine times 5 halves x. And that would have been the function to create this curve. How's that feel? Okay? Everybody good? Everybody at home, does that feel a little bit better? Hopefully, again, if you haven't tried the homework yet, you wouldn't know. But if you have seen the homework, maybe that helps a little bit. I'm not sure. All right? Okay. So tomorrow, I have one more thing I have to show you from 6.4, and then we will have seen all of section 6.4. And then we'll do 6.5, and then that's it. After 6.5, we need to get to chapter 7, guys. I need to get to chapter 7 with you guys. Okay. All right, well, you have no new homework assigned. You still have that 6.4 day 1, day 2 that is due tomorrow night. If you need any help, please let me know. Otherwise, let me just double check your attendance, and you guys will be good to go.